you're just looking for continuity and you're looking for the presence of voltage. So here's a perfect example. We're going to use my demo board here today. Perfect example of a case where you might need an electrical meter to find out what wire is what and where things are going. We're going to pretend that you're going to switch this old keyless fixture out here and you're going to put in a different light fixture. Well, here's the wiring as it is now, and what we're going to do is pretend that you just took apart all these splices and now you don't know what wire goes where. Okay, so here's what typically happens. You're going to change this light fixture. All you know is that this switch used to turn on that light before you messed around with it. You've taken apart all the splices. You went to hook up your new light fixture, and no matter what combination you use, things don't work the way they used to. Either the light's on all the time, or you turn the switch on and the breaker trips, or the light just doesn't work at all. So now you call me, you're asking me for help in this. And without a meter, the only way to figure this out is trial and error, and believe me, using a meter is much quicker. So what we've got in a case like this is 3 sets of black and white wires. Now, being there's no 3 wires in this situation, I know that this circuit is likely wired with only 1 switch in the situation, no 3 ways involved. This is likely power in. One of these is going to be your supply. One of these cables will be your power out to the rest of the circuit. And one of these is going to be a switch leg drop down to the switch. Typical wiring situation. Now, if the electrician in this case had marked the white wire with a piece of black tape, as he should have, to the wire that goes down to the switch, the hot wire in the switch leg drop, this would be a little easier to troubleshoot. But in this case, someone got sloppy, didn't mark the wire, and keep in mind that here I can trace the wires because I can see them. But with the wall board on and the drywall in place, you have no idea what cable goes where. So here's how I'd instruct you to troubleshoot this circuit. We need to strip all these wires and do some tests. So that's what we're going to do, is strip the wires, and I'll explain the testing that we have to do to determine which one is the switch, which one is power in, and then we can determine which is power out. Okay, so the first thing you want to do is make sure the power is off. I know you've probably tripped that breaker 1,000 times and you know off by heart which one it is in the panel. However, before you start playing with the open wires, you want to check to make sure there's no voltage there. So setting our meter on volts AC, in this case it's a capital V with a sine wave or a little squiggle above the V, that's voltage AC. So we want to check each pair from hot to neutral and make sure we have no power there. So we check here, no power, and we'll also check hot to ground, just to make sure. No power there, 0.00063 volts. Move over to the other pair's hot wire, no power there. Go back off the ground and check to neutral. No power there. And again, we'll check the other hot wire, hot to neutral. Hot to neutral, nothing there. And we'll just go hot to ground on that last pair as well. No power. So, now that we're sure we've got no voltage, now we can check to find out which of the wires goes down to the switch. Now, all a switch is opening or closing a circuit. So, with your ohms, or your resistance check, you can tell if that circuit is being made or broken. So, we go to ohms. This is an auto-ranging meter, so you don't have to worry about range. Now, remember, low resistance means a good circuit. So, touch these 2 leads together of the meter. We got 0.22 ohms, which is a very low resistance to current flow, so you have a closed circuit there. So same thing, if we turn the switch off or on, you'll see the same thing. An open or a closed circuit. So we put the leads on one of the pairs of wires. Open, so we have a little bit of resistance there. That just tells me that that's likely going to another part of the circuit, and there might be a lamp plugged in or something. We've got a little bit of resistance there, but we do not have low resistance or no resistance by turning the switch on and off. So that pair of wires is not our wires going to the switch. check the other pair. Oh, there we got mega ohms, so we know that there is no switch there. Turn the switch on or off, doesn't make any difference. Here, try this pair of wires. Open circuit, turn the switch on. Oh, there we go, right back to 0.3 ohms resistance. So we know that that is the switch. It's open, turn the switch on, it's closed. So that's the circuit, or the wire I should say, going to your switch. Now we're going to identify this wire as the hot. Whenever you use a white wire as a hot conductor, you want to identify it with either a little piece of black tape or color it in with a felt pen. That should have been done in this case, and it would have saved us a little troubleshooting, but we'll get that done, and then we'll go turn the breaker on and we'll find out which one of these wires is the hot wire coming in. Alright, so now you see I've marked the white wire with a piece of black tape. That's to indicate that that's the switch leg drop. Pulled back the black wire that goes with that, because we know that's the return from the switch now. I've turned on the breaker, set my meter back to voltage AC again, and now I'm going to check to see which one of these cables coming in is the hot supply wire. Checking here, I've got 0.02 volts, so nothing there. Move over to neutral. That doesn't really matter, but you should put your common as your black wire, or sorry, your common black lead off your meter should go to the neutral, and your red lead should be going to the hot black wire. And there I have 117 volts. So now I know this cable is my power into the circuit, which by the process of elimination means this one feeds power to the rest of the circuit, the rest of the receptacles on that circuit or whatever else might be on it. So now that we know switch leg, power in, power out, now I can help you. If you've asked me this question over the internet and you've done all this troubleshooting for me, now I can give you the proper instruction on how to connect this back up. Okay, so when you've got this apart, you want to make sure your ground wires are connected properly. So looking into the box here, I see that my box grounding or bonding strap is connected to one of the bare ground wires, and they're spliced together, and there's a little pigtail here, and that's in case your new light fixture has a ground spot to bond it or earth that fixture. You've got a pigtail hanging out here that can perform that function for you. Tuck that back in for now. Now remember, we have power in, which we determined is this cable. Power out is this cable, so they just basically need to be connected together. Everything needs a neutral, including the light fixture. So we make this splice of the two neutral wires here, and if your new fixture already has a pigtail hanging out of it for connection to the neutral, then all you need to do is gently twist these two wires together, and for now we'll put a moret on it. And your neutral for your light fixture can get tied into this splice when we're ready for it. Next thing we'll deal with is our hot wires. So we've got power in to the circuit, power out of the circuit, out to the rest of the circuit I should say. So they need to be spliced together, along with this white wire that goes down to the switch. It is now being used as a hot conductor and identified as such with that black tape. It gets spliced into the hot splice. And that connection is done. Put a moret on that. So now we've got neutral in, neutral out, and neutral to the light. We've got a hot wire in, a hot wire out, and a hot wire down to our switch. Back from the switch, the switch is on or off determines whether the light will be on. So now your light fixture gets connected between this black and the neutral. Okay, so for the purpose of our demonstration, I've put back the keyless fixture that we had here in the first place and made the splices, like I said, between the neutral and the black wire returning from the switch. Now it's time to turn the breaker on and make sure we've done everything right. Go to my room, turn on the light switch, and the light works. turn it off, and it's off. And I can use my meter to check the rest of the receptacles in the room to make sure they're all working and everything's back to normal. So you can see just how valuable it is to have an electrical meter in your toolbox. This is something that every do-it-yourselfer that attempts to work on anything electrical in there.
Okay. So I think these videos would have been much useful for you, and you would have enjoyed these videos actually. So if you have seen the video too, how to troubleshoot actually in electrical wirings, you should have, before like calling an electrician, you should have a multimeter. Digital multimeters are easily available in the market, and you should know the proper functioning of all these multimeters actually, right? And apart from that, you should have some knowledge of electrical wirings, like the diagrams and all those things. Nowadays, like, what is the future of these cables, wired cables actually? There is an important emerging area, that is like wireless communication, or like wireless sensor networks. Wireless networks are coming on actually. So what is the future of these wired cables? If you have seen that for transmitting the data, many of you will be using Bluetooth actually, right? Somebody will be using like this Wi-Fi's and all those types of connection, wireless communication. So what is the future of these wired cables actually? If you see, there is always a debate that is going on between wired and wireless communication, which one is more efficient. If you have seen, for Bluetooth communication, if you are using a Bluetooth communication, the data that you can transmit, that is the range actually, it is up to like distance actually, it is up to like 100 meters, right? So like if you are like way beyond, way far actually, up to like above 100 meters actually, so you can't transmit the data, right? So there is like you need actually wired communication, wire cables you need. Okay, apart from that, if you see Wi-Fi, there also, like, you can have in a building that you can have Wi-Fi connection, but if you want to have like entire this communication internet facility, you want to have in that entire city, you can't do with this Wi-Fi. So there also you need some type of like fiber optic cable and all those things for like audio video transmission. So apart from that, if you see, there are always a comparison between wired and wireless. Like if you want to extend the range of in wireless communications, like you have to create a node actually for transmission of data. There is one node actually, and in wireless communications, and if suppose if you want to extend the range, the length, that distance actually, so you have to create a second node depending on the distance actually you want to cover. Again, then in that there is a problem actually, there is a loss of data, because if second node gets destroyed actually, how to communicate with the second node actually, right? Apart from that, there are different like efficiency issues, then there are like battery issues actually. How long this wireless communication network is going to sustain actually. You need battery backup, so how much battery it is needed actually, right? How much power it is needed. So those kinds of concerns are always there in this wireless communication. Apart from that, depending on your environments, like if your moisture, your rain, all those things actually do matter in wireless communication. So if you see, there is always a comparison between wired and wireless communication. Both are equally good, both have like advantages and disadvantages. If you want a long data communication without loss of data, I think we should go for this wired communication. But if you want to have like this without wired, if you want to have limited coverage, limited area coverage actually, in that actually we should go for wireless communication. Again, price wise both are actually costly. So depending on the application, you should go for you should select whether a wired or wireless communication. For this wired, for this lecture, I use some materials actually. You should go for those materials actually. There is one book actually that gives a good information about this cables and connectors and wires. That is written by, I think, Raghunath, PHI publication actually. Right, in the net itself you can have much data, right? So this is what I did actually about these cables, and I think I will summarize what we did in today's session. We looked actually the type of cables actually, what is cables, then what is wires, leads, flex, and then we went we discussed about different types of cables, their applications, advantages, disadvantages, and then again how to choose a cable actually. Different criteria are there for selecting a cable. Then we saw actually that how to identify different wires or cables. So all those things are very important, and I think it would have given you some idea. We went for this, we saw actually some videos, so I think this would have given you some idea. Okay, for like any queries, suggestions, your feedbacks, actually you can always contact me on my email ID, that is sachin.sharma@bapugkv.ac.in. Thank you from my side.